Not running on.
All right.
I'm scared you put.
You scared me.
Well, what do we do?
So the second derivative of f of x is given by this function, this equation. How many inflection points does it have? Provide evidence to support. So the idea here is the inflection point for the second derivative is equal to 0. So they give you all the factors, which is nice. So we have possible inflection points. So here, possible inflection points at x equals -3, 2, and 4. Now, to provide evidence, the evidence would be to draw a number line. We have -3, 2, and 4, and pick values around that. So let's say -4. Well, -4. -4 is fine. 0, 3, and 5. Now the goal is to see, do the signs change after -3 or 2 or 4? Do the signs change around those values? Now, no matter what I plug into the function, I will get a positive here because it's being squared. Okay. So if I plug in -4, that's going to give me a negative, and a negative, a negative, positive, negative gives me a positive. Okay. So that means it's concave up here. All right. Not that as much to what we're dealing with. If I plug in 0, that's going to give me a positive, positive, and a negative, which is negative. So actually, there is an inflection point. So x equals -3 is an inflection point. Well, let's hold off. We'll put both. I think you have two answers here.
So one, do you have to say do you have to say possible, or is that like a?
No, I'm just putting that up there for you guys. So we have x equals -3. That's an inflection point. So we're going to test 3. If I plug in 3, I get positive, positive. Still negative here. So that's going to be negative still. So 2 is not an inflection point. All right. If I plug in 5, I get positive, 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 which means -3 and +4 are inflection points. All right. Yeah. So because f prime of x, f double prime of x changes signs. So that's really it. That's your test. Test if you have inflection points. There it is. To find critical values, no. I don't think so. I don't think I have something that says specifically use the second derivative test. All right, find the interval in which f is decreasing. Now, here's the thing. Okay. What kind of function is this? Parabola. And we know it's opening in what direction? It's opening up. So we know it's decreasing from -infinity up until it turns. So really, we can just take the second derivative, find the x value in which it has its turning point, and there you go. From -infinity up to that value, you're done. Okay? You know it, and I know it. Okay? But you do need to be able to explain how. So to explain how, you still have to do your number line. Okay? Yes.
Can you like theoretically find the vertex?
Yeah, that too. But honestly, it's faster just do the derivative and set the derivative equal to 0. Actually, negative b over 2a is not too bad either. Yeah, that's not too bad. Honestly, I don't know which one's actually faster. Because the derivative is just what? 2x minus 8, so x equals 4. Negative b over 2a is -8 over 2, which is also -4. Actually, +4. So either way, you get what? X is 4. So f prime of x is equal to 2x minus 8. 2x minus 8 equals 0. so x equals 4. And you have your value. So you plug in 3, or you can just plug in 0 even, and you plug in 5. So if you plug in 0, you get negative. Plug in 5, you get positive. So yes, right here, from neg infinity to 4, f of x is decreasing because f prime of x is negative. So that's your explanation. We know it's decreasing because we know the derivative is negative.
First derivative.
Yep. Determine the constants a and b so the function will have a critical point at 1, 2. All right. Well, let's do the derivative. G prime of x is equal to 3x squared plus 2ax. All right. We can factor out an x, so 0 is equal to x times 3x plus 2a. And we know that the critical point is at 1, which means if I plug in 1, I should get 0. All right, so if I plug in 1, I get 0 is equal to 1 times 3 plus 2a. So 0 is equal to 3 plus 2a. Subtract 3, a is equal to negative 3 over 2. I don't think this is on your test. I don't know this being on your test. It's a good question. Why isn't something like this on your test?
Wait, you made us.
Not that I can't add it because I don't want to make your test any longer.
Do the next step.
I just like this question, so I'm just like, it's not hard. So, what you do to find b is you plug in 2 and 1 into the original function now that you know what a is. So, since 2 is equal to 1 cubed plus negative 3 halves times 1 squared plus b, 2 is equal to 1 minus 3 halves plus b, so 2 is equal to 1 negative half plus b, so b equals 5 halves. Or 2.5. No.
Okay, oh, I'm sorry, just confused. Where did the x go after the second 0 equals? It turned into 1. Why?
Yeah. Because we know that, so the critical point is at 1, so it means x has to equal 1. So is that one test here? No. Nope. Not in your test. It's a shame. It's a good question. All right, this is the one I do want to focus a lot of time on. Okay, state the x values for the local minimum, justify your answer. State the x values for point of inflection, justify your answer. Okay, so this is going to be a big portion of your test is being able to do this and justifying your answer. So this is the graph of f. All right, be careful. Oh, it's a graph of f prime, even better. That's why you want to be careful. It's a graph of f prime, even better. Okay, so the graph f prime tells us a couple things. Okay, number one, everywhere the graph crosses the x-axis is a possible turning point. So here and here. And well, you can't say here because that's an endpoint. So yeah, 2 turning points here and here. Okay, where this could be, in fact, since this is positive, then going from positive to negative, that's increasing to decreasing, this would be a local max. Okay, and this would be a local min. Because you have a local max when f prime changes from positive to negative, local min when it changes from negative to positive. All right. Now you do have to be careful. So let's go through this. So say the x values for the local minimum f, we just said it was what, 2? X equals 2. F prime of x changes from what? From negative to positive. And that is exactly how you need to state that. All right. Now state the x values for the points of inflection on f. Now, in order to have a point of inflection based upon your derivative, it's where your derivative has a turning point or where your derivative is not differentiable, okay? And it changes from increasing to decreasing. Okay? So we have 3 points where the function is not differentiable. Here, here, and here. Only one of these does the function f prime change from increasing to decreasing. And which one is that? At 3. So x equals 3, okay? Because f prime of x is not differentiable. And f prime of x changes from increasing to decreasing. It needs both of those properties based on the first derivative. All of our reasons are going to be based on the first derivative. All right. Why does it have to change from increase to decrease? Why can't it just be not differentiable or where it has a turning point? Why does it specifically have to change from increasing to decreasing?
Because the second derivative would go from positive to negative.
There you go. Where the first derivative is increasing is where the second derivative is positive. And where the second derivative is positive, it is concave up. Where the first derivative is decreasing, it is the second derivative is negative, and where the second derivative is negative, the function's concave down. So we do need to see where the second derivative changes from concave up to concave down. If not, it stays concave up or concave down. If it doesn't change direction, yes. It could be a turning point. So we just don't have one of those. Well, actually we do, don't we? I'm missing one, aren't I? I am. I'm missing one. Good catch. Which one else am I missing? X equals 0. Okay. So here, turning point, f prime of x has, let's say, a horizontal tangent. And changes from, in this case, what? Decreasing to increasing. I mean, you could probably also say that the f double prime changes signs, because it would. The second derivative would change signs at those points. That would be a whole lot easier than changing from increasing to decreasing. All right, what interval is f increasing. Now we have this first derivative. Where is the function increasing based on the first derivative? Where it's positive. So increasing on the interval from -6 to -2, union 2 to 1, 2, 3, 4, 5, 2 to 5. Okay, f prime of x is positive. That is all the justification you need. All right. And D is a really good question. Okay. You will have something similar to this on your test. I mean, all of these, you're going to have something similar to all of these on your test. You're just going to have a different graph. Okay. So, for which intervals is f decreasing and concave down? All right. Now, in order to be decreasing and concave down, that means where is, for decreasing, where is f prime of x? Negative. Okay. And that's where? Negative 2. Now, where is it concave down also means where is f prime of x decreasing. So not only where is f prime of x negative, where is it decreasing? Negative 2 to 0. So it is decreasing and concave down from -2 to 0.
Oh, let's say
0, because f prime of x is negative and decreasing. That is your justification. Again, this set of questions is worth a lot of points. So I want to say your test is like 50-something points. This is 16 of them. Okay. And again, half the points are the justification. So suppose the function f contains the point 2, 1. Find the equation of the line tangent to f at that point. All right, 2. Where did f go? Oh, here it is. So we're looking at 2, 1. So right here, right? Well, what do we know about f prime of x crossing the x-axis? That's a local, in this case, it's a local minimum. So it means that the slope is what? Because that's the slope. Slope is what, 0? Here, slope is 0. So y equals mx plus b, y equals 1. There's your equation.
But since it's a theoretical fund, how do we know it's this looks here?
Because what is happening at x is 2 in the graph? Remember, the derivative gives you the slope at any point of the function. So what is the value of f prime at 2? 0. So since f prime of 2 is equal to 0, that is your slope. Yeah. I don't think I put that. That's kind of just too basic. I don't think I put that on the test. So, all right, and then you have at least kind of 2 of these. You have one that deals more with your rectilinear motion with the position, velocity, and acceleration. Okay, so how to maximize velocity or maximize acceleration or minimize velocity or acceleration, something like that. Or to find the max velocity or acceleration. Okay. So I think we had a question like that already, didn't we? Yeah, right here. So find the maximum velocity, which means we need to find the velocity first and then take the derivative of that. So same thing, if I want the max acceleration, I need to find the acceleration function and then take the derivative of that. All right, but these are more of your optimization, straight optimization questions. So supermarket employee wants to construct an open top box from a 16 by 30 foot piece of cardboard. So we have 30 by 16, cutting x by x squares, same size sections of squares out. What size should the squares be in order to create a box with the largest possible volume? All right, so volume is equal to length times width times height, and the height of my box will be x, because when you fold here, okay, when you fold here, you will have a box that is height of x. And it's real fun to draw 3D shapes. Now your length is going to be 30 minus 2x because you took off x here and here. Your width is now 16 minus 2x. So volume is 30 minus 2x, 16 minus 2x times x. So that is a number. What?
If you really switch the 30 and 16, like say length,
Oh, it made a difference. Yeah, you just turn the box and there you go. So 30 times 16 is 480. Minus 60 minus 32, so minus 92x plus 4x squared, and then all times x. So it gives you x squared and cubed. All right. So it gives me volume. Well, again, I want to find the derivative, so I'm going to take the max value. So I take the derivative of this. So I can put this in order as 12x squared minus 184. X plus 480. And I think I can divide that by 12. It's divided by 12. Nope. Mint. Nope. Oh, that's not fun. And divide. Okay, divide one. Four. That's fun. So V equals 0 is equal to, you can factor a 4. 3x squared minus 46x plus 120. Now, feel free to solve this however you want. Okay. So, however you like to solve these, I'm going to factor just because I like factoring.
nothing like calculates 40.
So 360 times negative 46, that would be what do you say the answer was? 6 and 10. Yeah, negative 36 and negative 10. So you have x minus 36 and x minus 10. So x. You guys ever done the divide by a?
Oh, you
So x equals.
uh,
So x minus 12 and x minus 10/3, which gives you x is equal to 12 and 10/3, but one of these doesn't work. Which one doesn't work?
Well,
12 doesn't work, it's too big. So 10/3. Now, that means that your height is, all they wanted was the x. What size should the square be in order to create a box? So yeah, 10/3 by 10/3. And this is centimeters.
why would 12 be too big?
Plug in 12 and find the length and width.
50 minus 2.
16 minus 24 is -8. Yeah. One of them will always not work. Okay, one of them will either make it negative, obviously make it negative, or kind of separately make it negative in this case. Yeah. Mhm.
Will the one on the test like this factor this horribly?
That's not horribly.
Yeah.
It's easy enough to factor.
Yeah, but will it be like this or will it be?
It could be. I don't know.
You don't so man, the test.
I haven't taken it yet. Okay. Really should. Kind of have taken it anyway. I added this question onto the test because my BC calc, for some reason, was missing. So
And that's like,
That's the one thing I can.
when we like did some missing side
I have to say
on a barn or something, it's the side of a fence.
it's possible. What's wrong with us?
I just want to know what the setting. So yes or no?
It's possible.
No, it's like an
Possible.
Yeah.
And so we're-
It's not that hard. You just have to account for it.
Yeah, but the worst answer is I don't know if I should study or. Oh well, I'll just.
We should know it anyway. So it'll probably be on the AP test. All right, a company has started selling a new type of smartphone, price of 130 by plus negative 0.1x, where x is the number of smartphones manufactured per day. Parts for each smartphone cost $40, and labor overhead costs $4,000 per day. How many smartphones should the company manufacture and sell per day to maximize profit? Now, profit is basically revenue minus cost. Okay. So, in this case, profit would be the revenue of 130 minus 0.1x minus the cost of making, and that's that costs us each one. So that's 40x and minus 4,000. P is equal to, okay. Let's see here. Something's wrong here, though.
It's automatically be negative until you get negative.
There's a number seen for it.
Actually,
So that's the number of smartphones per day. And the cost of each smartphone,
first, the person make.
that should be X.
Why is there under X?
Let me see here.
Wouldn't the price of a smartphone be profit or?
The prices of our largest cost is the cost regional and like. I don't think this-
All I'm hearing is it's not profitable to make smartphones.
Well, not this smartphone.
That's this possibly make.
Why did you change your price based on how many you sold? Like,
It's how you can set the price as to how much you can produce. and make. Yeah, it's not about changing the price; it's about setting the price.
Let's
see here. Something I know something multiplied by X, because again, X is what? X is the number of smartphones manufactured per day, and then the parts for each smartphone cost $40, and labor and overhead for running the plant per day is 4,000 X.
No, it's not. It's not 4,000 X. X is the number of smartphones.
Oh, that's right. 4,000 per day.
4,000 per day.
Yeah.
And also, it should be.
So yeah, that's not that way.
Since you have minus inside parentheses, it should be plus 4,000.
No, it was times X. So both are a cost. But something's not right. I did this already. I did this already.
What did you do this? It's like this hair that can't even fall.
Local company starts selling a new type of smartphone.
Looking around and people are obsessed with house. Oh, it's like would it be 130x minus 0.1x squared? Or like when x is limited? Because if you get 130 for each phone you sell,
So you're thinking this should be
40. It should be 130x.
So that should be not 2x, but times x. Yeah, that's what I'm thinking. Something's being times x. So that gives you negative 0.1x squared plus 130x minus 40x. That's better. 1,000. So that gives you profit is negative 0.1x squared plus 90x minus 4,000. And we take the derivative, what do we get? It's trying to maximize profit. Derivative gives us negative 0.2x plus 90. So 0 is equal to negative 0.2x plus 90. That means 0.2x equals 90 divided by 0.2. X equals 450. Yeah, there it is.
Yeah.
The more you make in this case, the more you flood the market, and it's a supply and demand issue. So if you have more than you're going to sell, it's going to cost you more money, and you're not going to sell as many. So you have to lower the price to get rid of what you have. So this is a way of a kind of again, this is idyllic situations. There's always other things that go into producing things, but this is the very common concept of trying to find a price value outside of just capitalist greed. Okay. So, all right, that is your test review. That's all of them, right? So, on your test, let's see here. I have your test right here. Sure, just do that. Yeah, that. You will need to know the concept is if this is the function. Okay. When is f prime positive, negative? When is f double prime positive, negative? When are they 0? Okay. Because that'll pertain to quite a bit. All right. Given a function, okay, given an actual function, so I have one somewhere. Yeah. So given functions, when find your points of inflection, make sure to justify your answer. Okay. So yeah, make sure to do the number line, just because reason being is you may get 2 points of inflection, but they both may not be actual true points of inflection. You have 2 possible points of inflection. Check, because only one of them may work. Okay. A lot of people I know in BC got things wrong because they didn't think to check. All right, know your mean value theorem. Where's that at? Mean value theorem. So yes, this question number 9 is definitely going to be on your test.
Number
What?
Or number what? 4. I don't know what number you have. Don't know what number this is on y'all's. 5. Okay. So yeah, this question's going to be on there. Okay, just not in the same format. You may have to find f of a and f of b on the test. They won't give you f of a and f of b. Okay. Let's see here. All of these true, like multiple choice questions. These are going to be very similar to what's actually in your test. So be able to answer any of these. Okay. You may not be given a chart, but you may be given a graph. Which in a graph you'll have actually a bit easier answering some of these questions. I think that you have every value. So, but similar concept. You're going to answer something very similar to this. Local min, local max. Okay. Is it differentiable, concave up, stuff like that. All right. So, this question number 10. Okay. Just again, a little bit different, but same concept. All right. Those optimization questions we just did. And yeah, no, well, yeah, just one optimization question. Okay. But it's going to be a little bit of a mix. Yeah.
terrifying.
It's not that bad. Just really read the question. Okay. That'll be fine. Okay. Let's see here. All right. I don't think you have a question on number 11, but yeah. No, I think you will have a question like this. Number 9 will be. You have 2 questions involving the mean value theorem. Just one is a lot like number 9, and one's a little bit like number 9. I think one asks you to verify that this must exist, and one asks to actually find C. Yeah. And then, yeah, these questions that I told you about. This isn't on your test. This particular thing, this is not on your test, but it's really good practice for one of the questions that is on your test. And like I said, knowing when looking at a function, when is f prime positive, when is f double prime positive or negative, stuff like that. And then these questions I asked you down here. Number 8. Well, I don't know what number that's for you, but given the graph function, find the local minimum, find the inflection point, find where f is increasing, find where it's decreasing, concave down, basically, and justify your answer. That'll be interesting. And there is one bonus point, or bonus question, but it has 4 parts. It's not bad. It's kind of. It's bonus, so. Right. If you've done your AP work, it shouldn't be that bad. Yeah, it's. I said if you've done your AP work. All right. Yeah. Just make sure to test your stuff. Yeah.
So on this one was where it's decreasing.
And look at that. Yeah.
So it has to be
Has to be-
and concave.
yeah, so it has to be below the x-axis because that's where the f is decreasing, is where f prime is negative. And to be concave down, f prime must also be decreasing.
Okay, so if it just said where f is decreasing, this would also be part of it.
If it just said where f is decreasing, it would be the entire thing from -2 to 2 because that's
Okay,
where x prime
So
is.
it's okay because it says concave. Okay,
Yeah.
that makes sense.
Yeah.
Because that f double prime would be negative.
And f double prime would be negative when. So if you want to know where it's concave down, then that would be everywhere from -6 to 0, and then from 3 to 5. It's concave down because that's where that's where f prime is decreasing.
Okay,
So
that
where
makes sense.
yeah.
All right.
Or is it catch up?
You don't have everything. Even whether you
How much are you making? We're up to 5. I've waited, this is the one.